May 17, 1943. Kriegsmarine Intelligence Assessment Room, Berlin. The morning light filtered through tall windows overlooking a city scarred by Allied bombing, casting long shadows across the oak table where Kapitän Heinrich Müller sat surrounded by technical diagrams, salvage reports, and photographs of objects that should not have existed.
Before him lay the remnants of devices recovered from the Atlantic. Cylindrical canisters no larger than a man's forearm, bristling with hydrophones and radio antennae. Their construction so sophisticated that German engineers had spent weeks simply understanding how they functioned. These were Allied sonobuoys, air-dropped acoustic sensors that had turned the vast Atlantic into a monitored grid where German U-boats, once the invisible predators of the deep, now moved through waters that listened and reported their every sound. Müller held one of the devices, feeling its weight, examining the precision of its machining, the miniaturization of its electronics, the engineering that allowed it to survive impact with the ocean, deploy automatically, transmit acoustic data to circling aircraft, then sink without trace when its battery expired. The room was silent, except for the ticking of a wall clock and the distant rumble of Berlin's damaged infrastructure being repaired. Around the table sat the men who had built Germany's U-boat campaign, naval architects, acoustic specialists, intelligence officers who had spent years developing tactics to counter Allied anti-submarine warfare. They had gathered to review Müller's assessment, to understand what these recovered devices meant for the Battle of the Atlantic, to confront the reality that their careful analysis had revealed. The Sonobuoys represented more than advanced technology. They represented a fundamental shift in naval warfare that Germany had neither anticipated nor could counter. The Atlantic, which had been Germany's hunting ground, where U-boats operated in the vastness of empty ocean beyond the reach of enemy detection, was no longer empty. It was monitored, surveilled, transformed into a battlefield where acoustic sensors dropped from aircraft created surveillance networks that tracked submarine movements across thousands of square miles. And the implications, which Müller would present in his report to the Oberkommando der Marine that afternoon, were stark and unavoidable. The Battle of the Atlantic was lost, not through any failure of German tactics or courage, but through Allied technological superiority that had made submarine warfare, as practiced by the Kriegsmarine, obsolete. The Battle of the Atlantic had been Germany's strategic opportunity to strangle Britain, to sever the supply lines that kept the island nation fighting, to demonstrate that sea power, properly applied through unrestricted submarine warfare, could win wars that surface fleets could not. From 1939 through early 1943, German U-boats had enjoyed remarkable success, sinking millions of tons of Allied shipping, operating with relative impunity in the vast expanses of the Atlantic, where Allied patrol aircraft and escort vessels were too few and too limited in capability to provide effective protection to convoys. The U-boat commanders had developed tactics, wolf-pack attacks coordinated by radio, night surface assaults that exploited U-boat speed and maneuverability on the surface, deep diving to evade depth charges that made them among the most effective naval forces of the war.
Dönitz's U-boat arm was built on the principle that the Atlantic was too large to be fully patrolled, that submarines operating in coordinated groups could overwhelm escort defenses, that the sheer volume of Allied shipping meant targets would always be available. German naval planning assumed that even with losses, U-boat production could sustain a campaign of attrition that would eventually force Britain to negotiate. This assumption was reinforced by early success. In 1942, U-boats had sunk over 1,600 Allied ships. The tonnage destroyed exceeded Allied shipbuilding capacity, meaning the merchant marine was shrinking even as Britain's need for supplies grew. U-boat commanders returned from patrols with multiple kills, their crews decorated, their boats celebrated. The Atlantic belonged to Germany, or so it seemed. But beginning in spring 1943, something changed. U-boat losses, which had been sustainable at roughly 10 to 15 boats per month, suddenly spiked. In May 1943 alone, 41 U-boats were destroyed, losses that exceeded Germany's construction capacity and represented nearly a quarter of operational boats. Surviving crews reported increasingly effective Allied tactics, aircraft appearing suddenly over boats that had been running on the surface far from known patrol areas. Depth charges delivered with uncanny accuracy to boats that thought they had evaded detection. Coordinated attacks by multiple aircraft and surface vessels that suggested the Allies knew where U-boats were before visual contact was established. German naval intelligence scrambled to understand. Had the Allies broken German naval codes? Were they using new radar systems U-boats couldn't detect? Had spy networks compromised patrol areas? The answer, when it finally emerged from technical analysis of recovered Allied equipment, was more disturbing than any of those possibilities. The Allies had changed the fundamental nature of anti-submarine warfare through technology that made the ocean itself a detection system. The sonobuoy that Müller examined had been recovered from the North Atlantic in April 1943, retrieved by a U-boat crew who had surfaced after evading an air attack and found the device floating nearby, its transmission complete, its battery exhausted, waiting to sink. The crew, trained to collect intelligence, had recognized it as potentially significant and brought it back to base. When German acoustic engineers began their analysis, what they discovered challenged assumptions about what was possible in miniaturized military electronics. The device was a self-contained acoustic surveillance system designed to be dropped from aircraft into the ocean, where it would deploy automatically, listen for submarine sounds using sensitive hydrophones, and transmit that acoustic data via radio to the aircraft that had deployed it or to nearby patrol planes. The sonobuoy operated passively. It made no sound itself, only listened, which meant submarines had no way to detect its presence. It could be deployed in patterns, creating acoustic detection grids across convoy routes or suspected submarine transit areas, effectively extending the surveillance range of patrol aircraft from a few miles of visual observation to hundreds of square miles of acoustic monitoring. And the technology revealed in its construction suggested the Allies were producing these devices in quantities that allowed their widespread use. The electronics were miniaturized beyond anything Germany had achieved in portable military equipment. The hydrophones were more sensitive than the acoustic sensors used in German U-boats for detecting enemy shipping. The radio transmitter, operating on frequencies German boats weren't monitoring, had sufficient power to reach aircraft at altitude despite the device floating at sea level.
The battery chemistry allowed hours of operation in saltwater conditions. The mechanical deployment system, parachute, sea anchor, scuttling mechanism, functioned automatically without requiring any human intervention after the device left the aircraft. Every aspect spoke to manufacturing sophistication and resource abundance that Germany's war economy, stretched across multiple fronts and under constant strategic bombing, couldn't replicate. Müller's analysis, documented in the technical report that would circulate through German Naval Command over the following weeks, traced the Sonobuoys' impact on U-boat operations with methodical precision. The device had been introduced by Allied forces in late 1942, initially in small numbers and limited areas, then expanding rapidly through early 1943 as production increased and tactical doctrine evolved.
The Sonobuoys were deployed by long-range patrol aircraft, American Liberators and Catalinas, British Sunderlands and Wellingtons, that could cover vast areas of ocean during single sorties. When a convoy was threatened or U-boat activity was suspected in a region, aircraft would drop sonobuoy patterns ahead of the convoy's route, creating acoustic barriers that detected any submarine attempting to maneuver into attack position. The acoustic data transmitted from the sonobuoys allowed aircraft crews to localize submarines with far greater precision than visual searches or primitive radar could achieve. Once localized, aircraft could deliver depth charges, homing torpedoes, or guide surface escorts to the contact. The system transformed the fundamental tactical equation of submarine warfare. Previously, U-boats could exploit the vastness of the Atlantic to avoid detection, surfacing at night to charge batteries and transit at high speed, diving when aircraft were spotted, confident that the chances of being detected in the enormous expanse of ocean were minimal. With sonobuoys, that vastness became a surveillance grid. U-boats running submerged to avoid radar detection made noise, propeller cavitation, machinery vibration, hull sounds that sonobuoys detected at ranges of several miles. U-boats attempting to transit to patrol areas found themselves detected, tracked, and attacked in regions they had considered safe. The psychological impact on U-boat crews was severe. Submarine warfare had always been dangerous, but it had been a calculated danger, where skill and tactics could improve survival odds. Now, crews described a sense of being hunted by invisible observers, of the ocean itself becoming hostile, of attacks that appeared without warning in areas where they thought detection was impossible. The technical sophistication of the sonobuoy was matched by the tactical sophistication of its employment, and this combination proved devastating. Allied patrol aircraft had developed systematic search patterns that maximized sonobuoy coverage while conserving the devices for highest value targets. When a U-boat was detected, aircraft would drop additional sonobuoys to track its movements, using the acoustic data to predict the submarine's course and position, even when it went deep or attempted evasive maneuvers. Multiple aircraft could share sonobuoy data through radio relay, creating coordinated attacks that approached from different directions simultaneously. Surface escort vessels guided to sonobuoy contacts by aircraft could deliver sustained depth charge attacks that forced submarines to deep depths where battery life became critical and the risk of hull damage increased. The sonobuoy enabled what military theorists would later call network-centric warfare, distributed sensors feeding data to multiple attackers, creating a coordinated response that no single platform could achieve alone. German U-boat tactics had no effective counter. Boats could not detect sonobuoys to avoid them.
Running deep and slow to minimize acoustic signature reduced operational capability. Submarines became so cautious that they couldn't maneuver into attack positions against convoys. Surfacing to use high speed and recharge batteries meant exposure to radar-equipped aircraft. Remaining submerged exhausted batteries and made boats vulnerable to systematic depth charge attacks. Every option available to U-boat commanders had been degraded by the Sonobuoys' presence. The Atlantic, which had seemed infinite and anonymous, had become a monitored space where submarines operated under constant surveillance they couldn't evade. The intelligence reports that accumulated through spring and summer 1943 painted a picture of systematic defeat. U-boat crews who survived attacks reported similar patterns: detection far from convoy routes, attacks that began suddenly with accurate depth charges or homing torpedoes, the sense that Allied forces knew their location before visual contact.
Post-patrol debriefings revealed declining morale as experienced crews recognized that survival was increasingly a matter of luck rather than skill. The mathematics of U-boat warfare, which had favored Germany when Allied detection was sporadic and U-boat numbers were sufficient to overwhelm escorts, had shifted decisively. Now, every patrol faced high probability of detection. Every detection faced coordinated attack from aircraft and surface vessels. Every attack had increasing probability of sinking the boat. German U-boat losses in the second half of 1943 made the strategic situation undeniable. Over 240 boats sunk, representing both operational submarines and new construction, with replacement rates unable to sustain force levels. The crews lost included experienced commanders and trained submariners who couldn't be replaced at the rate they were being killed. Dönitz, who had championed U-boat warfare as Germany's strategic weapon, faced the reality that continuing the Atlantic campaign meant sending men to die in a battle that technology had made unwinnable.
In August 1943, he temporarily withdrew U-boats from the North Atlantic, the first admission that German naval forces could no longer contest Allied control of the convoy routes. The withdrawal was presented as a tactical adjustment, but within naval intelligence it was understood as recognition that the Battle of the Atlantic was over.
Müller's final report to the Oberkommando der Marine, submitted in June 1943 and classified as top secret, concluded with assessments that read like an obituary for German naval ambitions. The Sonobuoy represented a category of technology, miniaturized, mass-produced, networked, that Germany's war economy couldn't match. Each device required precision manufacturing, exotic materials, advanced electronics, and quality control that German industry, even under optimal conditions, would struggle to replicate. Under wartime conditions, with factories under bombardment, skilled workers conscripted, materials diverted to multiple competing priorities, and production schedules driven by immediate crisis rather than long-term planning, Germany had no realistic path to developing equivalent systems. But even if Germany could produce Sonobuoys, the larger system they enabled, long-range patrol aircraft with sophisticated communication systems, coordinated air-sea tactics, the logistics to deploy and sustain surveillance networks across the Atlantic, was beyond German capability. The Sonobuoy wasn't a wonder weapon that could be copied to reverse German fortunes. It was evidence of a fundamental disparity in how the two sides approached warfare. The Allies had transformed anti-submarine warfare from a tactical problem into a systems problem, creating interlocking technologies and doctrines that made submarines vulnerable through surveillance rather than through direct combat. Germany's response to U-boat losses had been tactical: improve torpedoes, add radar warning receivers, develop snorkel systems for submerged battery charging. But tactics couldn't overcome systemic disadvantage. The report noted with cold precision that the Sonobuoys' acoustic sensors were likely produced by the thousands or tens of thousands, deployed liberally across the Atlantic, treated as expendable rather than precious. This profligacy was possible because American industrial production had made sophisticated electronics a commodity rather than a carefully rationed resource. German acoustic technology was comparable in quality, but German production could never match Allied quantity. And in warfare, quantity of adequate technology often defeated quality of limited technology. The Sonobuoys' presence in the Atlantic was therefore not just a technical challenge, but an economic reality. Proof that the Allies could afford to wire the ocean with sensors, while Germany struggled to maintain U-boat construction rates. The psychological transformation within the U-boat force was documented in letters, patrol reports, and post-war testimonies that revealed how technology had undermined morale more effectively than combat losses alone could achieve. Experienced U-boat commanders who had hunted Allied convoys with confidence in 1940 and 1941 described by 1943 a sense of being prey rather than predator. The ocean, which had been their element, their advantage, had become a trap where survival required constant vigilance against an enemy who seemed omnipresent. Young crews on their first patrols learned quickly that the romantic image of U-boat warfare, the lone submarine stalking enemy shipping across empty seas, bore no relation to the reality of 1943, where every decision meant balancing the mission against survival, where experienced hands advised extreme caution, where returning from patrol without achieving anything was considered success if the boat survived.
One commander, Kapitän Lieutenant Ernst Bauer, wrote in his patrol log after a frustrating mission in July 1943, "We are no longer hunters in these waters. We are hunted, constantly, by enemies we cannot see or counter. The ocean itself seems to have turned against us. Every sound we make a betrayal of our position, every movement tracked by invisible observers. I ordered deep diving 3 times today after detecting aircraft at extreme range, and each time we remained submerged for hours, creeping at minimum speed to avoid detection, never knowing if the hunters above us knew our location or were simply patrolling randomly. This is not warfare. This is slow death postponed by caution and luck, neither of which can sustain us indefinitely." Such assessments, multiplied across the U-boat force, created a collective recognition that the Atlantic campaign had become a war of attrition Germany was losing. The Sonobuoy became, for German naval intelligence and U-boat crews who learned of its existence, a symbol of Allied technological supremacy, in the same way the proximity fuse and P-47 engine symbolized industrial disparity to other branches of the Wehrmacht. The device itself was not particularly impressive as engineering. It was clever miniaturization and integration of known technologies rather than revolutionary innovation. But its deployment in quantity, its integration into coordinated air-sea tactics, its effectiveness in transforming vast ocean spaces into monitored grids, demonstrated capabilities that Germany couldn't match. The Sonobuoy represented what American industry could do when resources were abundant, when production was optimized for volume, when doctrine could assume that technology would be available in quantities sufficient to blanket entire operational areas. German naval officers examining the recovered devices recognized excellence in manufacturing,
The precision of the machining, the quality of the materials, the reliability suggested by the design. But what struck them most was the implied scale of production. For the Allies to deploy sonobuoys across the Atlantic in numbers sufficient to affect U-boat operations, they must be producing thousands of units monthly, perhaps tens of thousands. This scale suggested an industrial base operating at levels German planners could only imagine, producing sophisticated military electronics at rates that treated each device as expendable ammunition rather than precious equipment. The psychological impact of this recognition was profound. German forces throughout the war had prided themselves on technical excellence, on engineering sophistication that compensated for numerical disadvantage. The sonobuoy suggested that technical excellence alone was insufficient when the enemy could produce adequate technology in overwhelming quantity, backed by logistics that sustained its deployment, integrated into doctrine that maximized its effectiveness. The Allied sonobuoy program had indeed achieved the scale that German intelligence suspected. By mid-1943, American factories were producing sonobuoys at rates exceeding 100,000 units annually, with quality control systems ensuring that the majority functioned as designed despite mass production. The devices were shipped across the Atlantic by convoy, stockpiled at air bases in Britain, Iceland, and North America, and deployed by patrol squadrons that treated them as standard ordnance, no different from depth charges or torpedoes. American and British patrol aircraft could drop sonobuoy patterns liberally, seeding suspected areas with sensors, creating overlapping fields of surveillance that ensured any submarine in the region would be detected. The tactical guidance for sonobuoy employment emphasized aggressive use. Aircraft crews were instructed to deploy devices whenever submarine presence was suspected, to create detection barriers around convoys, to saturate patrol areas with sensors rather than conserve them for confirmed contacts. This doctrine of abundance was possible because production exceeded consumption, because logistics delivered replacement stocks faster than squadrons could expend them, because the industrial base could sustain both the production of new devices and the continuous improvement of designs based on operational feedback. By late 1943, improved sonobuoy variants with better acoustic sensitivity, longer battery life, and more reliable deployment mechanisms were reaching operational units, while earlier models were still being produced in quantity to meet immediate demands. The production system was optimized not just for current needs, but for sustained output that could support expanding operations as more patrol aircraft became available and coverage areas grew. The German response to the sonobuoy threat evolved through 1943 and 1944, but every countermeasure revealed the underlying disparity between the two sides.
German engineers developed acoustic quieting measures for U-boats, rubber coatings to reduce hull sounds, improved machinery mounting to minimize vibration, propeller designs that reduced cavitation. These measures helped marginally, reducing detection range by perhaps a third under ideal conditions, but they couldn't make submarines acoustically invisible to the sensitive hydrophones in Allied sonobuoys. German Naval Command changed tactics, ordering U-boats to operate in regions where sonobuoy coverage was lighter, the South Atlantic, Indian Ocean, areas where Allied patrol aircraft were fewer and surveillance less dense. But these regions also had fewer targets, and the diversion of U-boats meant abandoning the strategic objective of interdicting North Atlantic convoys. German acoustic specialists worked on developing their own sonobuoy equivalents, but the program struggled with material shortages, competing priorities, and the fundamental challenge that Germany lacked the maritime patrol aircraft to deploy acoustic sensors even if they could be produced. A prototype system was tested in late 1943 but never entered production. German naval resources were diverted to schnorkel development, improved torpedoes, and defensive measures that might allow existing U-boats to survive, rather than offensive systems that required capabilities Germany didn't possess.
The asymmetry was stark. The Allies deployed technology that required maritime patrol aircraft, sophisticated electronics production, and coordination systems that worked across vast distances. Germany possessed none of these advantages at the scale necessary to contest Allied control. Every German countermeasure was tactical, local, incremental. The Allied Sonobuoy was strategic, systemic, overwhelming. Müller's career in the final years of the war reflected the broader trajectory of German naval fortunes. His technical assessments, accurate and unflinching, made him valuable to command, but also ensured he bore the burden of delivering assessments no one wanted to hear. By 1944, his reports documented the continuing degradation of U-boat effectiveness, new Allied technologies including improved depth charges, acoustic homing torpedoes, airborne radar that could detect periscopes and snorkels, even more sensitive sonobuoys that could detect submarines at greater depths and ranges. Each innovation was analyzed, documented, and assessed with the same conclusion. Germany had no effective counter, no path to regaining the initiative, no technology in development that could reverse the balance. Müller survived the war and contributed to post-war naval analysis, working with Allied intelligence officers to document German acoustic research and U-boat tactics. In interviews conducted in the 1950s, he reflected on the sonobuoy as the device that marked the definitive end of German Atlantic ambitions. His assessment was technical, but carried emotional weight. When we understood what the sonobuoy represented, not just the device, but the system behind it, the production capacity, the operational scale, we knew the battle was over. Not because we couldn't sink ships, we could and did throughout the war, but because we couldn't prevent the Allies from crossing the Atlantic with sufficient tonnage to sustain their operations. The sonobuoy made the ocean transparent to them and opaque to us. They could see where we were, we could only guess where they were. And in warfare, that asymmetry is decisive. All our tactics, our courage, our technical skill, none of it mattered against an enemy who could afford to fill the ocean with sensors and had the aircraft to patrol the data they provided. The Battle of the Atlantic's outcome was determined by multiple factors: code breaking, radar, long-range aircraft, escort carriers, improved depth charges, homing torpedoes. But the sonobuoy represented a particular kind of defeat, the transformation of war through technology that changed the nature of the battlefield itself. Previous naval weapons made ships more dangerous or harder to sink, but the sonobuoy made the ocean itself a sensor, a surveillance grid that detected submarines regardless of their tactical skill. This was industrial warfare applied to the electromagnetic and acoustic spectrum, where American productive capacity could create capabilities that German forces couldn't counter because they operated in domains Germany couldn't adequately access. The sonobuoy was cheap enough to deploy in quantity, effective enough to alter tactics, and integrated into systems that maximized its impact. And for German naval forces, the device represented a truth they had been slow to acknowledge: that the war's outcome would be decided not by who had the best individual weapons or most skilled warriors, but who could create and sustain systems of warfare that integrated technology, logistics, and doctrine into combined capabilities no single element could achieve alone. The Allies had achieved this integration in anti-submarine warfare. Germany had not, could not, and by the time the sonobuoy's significance was fully understood, lacked the time and resources to close the gap.
May 1945. The war in Europe ended with Germany's unconditional surrender. The U-boat fleet ordered to surface and sail to designated ports. The Atlantic finally at peace after 6 years of unrelenting combat. Müller, among the surviving officers who had witnessed the arc of the Atlantic battle from confidence through crisis to defeat, wrote a final assessment for post-war analysis that was less technical report than philosophical reflection. He described the sonobuoy not as a weapon, but as a messenger, carrying information about the nature of modern warfare that arrived too late for Germany to heed.
The device taught that oceans could be monitored, that invisibility could be overcome by sensors, that technology, deployed at scale, created capabilities that tactical excellence couldn't counter. The Allies had learned this and built their strategy around it. Germany had not, or had learned too late, or had lacked the industrial capacity to implement the lesson, even if it had been learned earlier. The result was visible in the tonnage statistics, Allied shipping losses declining sharply after 1943, U-boat losses increasing proportionally, the balance shifting so decisively that by 1944 the Atlantic was effectively an Allied lake where German submarines could operate only at prohibitive cost. The sonobuoy was one technology among many that produced this outcome, but it symbolized the approach that made the outcome inevitable. The device was not brilliant, it was systematic, not revolutionary, but thoroughly integrated, not precious, but abundant. These qualities, replicated across American military production, defined how the United States approached warfare in the industrial age. Excellence at scale, quality through process, overwhelming force through abundant resources. Against such an approach, courage and skill were necessary, but insufficient. Germany had learned this in the skies over Europe, when P-47s dominated through engine power and industrial production. On Pacific Islands, when proximity fuses made Japanese aircraft fall from the sky. On Atlantic convoy routes, when sonobuoys made submarines detectable. In each case, the lesson was the same. Industrial capacity, properly organized and sustained by logistics, created military capabilities that tactical innovation couldn't overcome.
The recovered sonobuoys that had triggered Müller's assessment in May 1943 remained in storage through the war's end, eventually transferred to Allied custody as part of the surrender arrangements. Some were studied by Soviet naval intelligence, which recognized their value and began developing similar systems. Others found their way to museums or technical collections, artifacts of a warfare revolution that had occurred beneath the waves and in the air above them, invisible to most participants, but decisive in outcome. The devices themselves were unremarkable to casual observers. Metal cylinders with some electronics, hydrophones, and radio equipment, nothing that spoke to their strategic significance. But to those who understood their role, the sonobuoy represented a particular moment in the evolution of warfare, when information became as decisive as firepower, when surveillance networks could dominate physical space, when industrial abundance could create capabilities that changed what was possible in combat. The Atlantic had belonged to Germany for a time, when U-boats operated in anonymity and Allied countermeasures were insufficient. Then, the Atlantic belonged to no one, when both sides contested control and the outcome remained uncertain. Finally, the Atlantic belonged to the Allies, when technology and industrial scale made German submarines targets rather than threats. The sonobuoy marked that transition, the moment when the ocean ceased to be empty and became monitored, when submarines lost their fundamental advantage of invisibility. The device was teacher and messenger both, carrying lessons about the nature of power in the industrial age, about how wars between modern nations would be won. And Germany learned those lessons, documented them, understood their implications. But understanding came too late, after the battle was lost, after the strategic situation had shifted irreversibly, after the time when knowledge might have changed outcomes. The sonobuoy floated in the Atlantic, listening, reporting, exposing the hunters to those who had learned to hear. And in that exposure, in that transformation of ocean into grid, the battle found its ending. Not through climactic engagement or decisive victory in single combat,
but through systematic application of technology that made one side visible and vulnerable while the other remained hidden and informed. The deep waters kept their secrets from those who hunted there, but the waters spoke to those who had learned to listen. And in that speaking, in that listening, the Atlantic changed hands, and the course of the war shifted with it.